Hello, everyone. Welcome to Spring One Tour. I'm your host, Bob Brinley. We're so happy to have you with us. Thank you again for joining us on this Wednesday. I think it's Wednesday. Sure, we'll call it a Wednesday. We're very excited to have Michael Manella with us today to talk data processing with Spring. Data. Let's go with the Star Trek pronunciation, data. How are you feeling this morning, Michael? Oh, you're muted.
Yep, I'm doing well.
Excellent. Data or data? Where do you lie on the?
I'm a data guy.
Data, got it.
And again, I'm also a Star Wars. I'm also a Star Wars guy. So
I am too, but I do appreciate some Star Trek. You know, I'm not like a line across the sand. You're on one side or the other. I can straddle. I'm leaning more towards Star Wars, but
there was a conference, I think it was last year, or the year before, that actually did T-shirts that combined the two. So it had the Millennium Falcon outlined with the call sign of the Enterprise on it one year, and then
you see, so. That is good. Yes, I've also seen the silly. It's kind of like, may the force be with you, long and prosper. You know, like it kind of combines some of the sayings and stuff like that. Yep. It's all fine. We're all good.
Exactly.
Anyway, you feeling good this morning? You feeling spry?
Yeah, let's do this.
Where are you based?
I'm out of Chicago, so I'm in the burbs of Chicago, but yeah.
You're it's like 11 o'clock for you, so you've been up for hours.
Yes, I have.
All right. Cool. Well, before we get to it, I just want to do a reminder at the top. If anybody has not registered for the Spring One conference, it's happening September 2nd and 3rd. It's all virtual. It's all online. So it's happening in your house. All you have to do is register by going to spring1.io. The agenda is out, everyone. The schedule has been made, painstakingly processed, and it is up and ready for you to view. 5 amazing tracks, along with a 6th social track. So, you can watch a whole bunch of great stuff about Spring and architecture and microservices. And then if you need to take a little break, you can do some yoga, you can listen to music, you can do whatever the social track has. There's great workshops, kind of get your skills up to speed, as well as the great social workshop tracks. So really just a lot of stuff. Go to spring1.io. It's a beautiful website, got tons and tons of great materials for you to peruse and register today. And also a reminder, today, Michael's going to be talking for the 2 hours. We'll take a little bit of a break in between. And then somewhat in the middle, it's not a perfect science, but just somewhere halfway-ish. And then if you have any questions, you please feel free to go to the Q&A. We've got Yvonne on the 1s and 2s trying to answer your questions. If he can't answer them, we might save them for tomorrow, because we do have the 1 hour Q&A, and we're actually brought in Oleg. I'm going to totally butcher the pronunciation of his last name. He's on, so maybe Oleg, do you want to say your last name for me? Unmuting? Or no? You don't have to. Let's keep him silent. How about you, Michael?
It's Oleg Zurkowski.
Say his last name? Zurkowski. Okay, good.
Zurkowski, that's perfect.
Wonderful. All right. He came. All right, cool. So so we have Michael and Oleg talking tomorrow, answering all of your questions. So if they don't get answered today, don't fret. Come back tomorrow, 9 until 10 Pacific Daylight Time. I'm learning there's a difference now between PST and PDT. Never had to worry about it before we started doing all these online presentations to people around the world. Yes, 9 a.m. PDT, and we'll have a great Q&A. And again, be nice to Yvonne. He's going to be doing the best he can, but he's great. And we're excited to have everybody on the team on. And Michael, we're just so ready for you to go. Are you ready?
I'm ready. Let's do this.
All right, let's do it. Well, without further ado, everyone, Michael Manella.
Thanks, Bob. Let's go ahead and get started. Go ahead and share my screen, because you don't want to see my ugly mug. And go ahead and do that. Cool. All right, so I want to start off by thanking everybody for taking a couple hours out of your day today to come and listen to me and learn about data processing with Spring. I know everybody's busy, and even more so now with the current conditions out there. So I do appreciate you taking this time. So a little bit about myself. My name is Michael Manella. I'm the co-lead of Spring Batch. I'm also the lead of Spring Cloud Task. I'm a committer on the Jakarta EE batch spec. I'm an author, speaker, etc. This is how you get a hold of me, any of these 3 Twitter handles. So at Michael Manell is my personal one, at Spring Batch is the one for Spring Batch, and I monitor that one, as well as I'm also a member of a podcast, which I'll get to in just a minute. I have a book out. If you're interested in batch processing, if you're interested in really a lot of the things we talk about today, because I get into some even broader things in the book, check it out. You can grab it there. I'm also on a podcast. It's a pundit podcast about the JVM. So it's a bunch of guys hanging out in a bar virtually lately, talking about just what's going on in the world related to the JVM space. So if that's something that interests you, please check us out. You can find us Java off heap, basically anywhere your favorite podcasts are streamed. Schedule for the 2 days. Bob mentioned it, but I'll go over it again really quick. Today, sorry, you're stuck with me. Tomorrow we'll have Oleg, who is a longtime Spring committer contributor. He's the project lead for Spring Cloud Function and Spring Cloud Stream. 2 of the projects we'll be talking about today as well. I'm going to be talking about some tech that we haven't released yet. So I got to put this statement up, basically saying don't hold us to those releases or that the functionality may change. What are we actually going to talk about though? Data processing. So it's kind of a loaded term if you think about it. It could mean just about anything in the compute world. When you think about it though, it really serves as the foundation of the enterprise computing world. It is really the processing of data and moving it around, transforming it, getting meaning out of data. So we've got data at rest, moving it around, getting meaning out of it. And that it really serves, like I said, as the foundation of the enterprise computing world. That's what we do, right? We get data in from users, we get data in from various IoT devices, machines, etc., and we generate meaning from it. So whether that be random numbers get meaning into financial transactions, or IoT sensor data that indicates that there's a vibration in my car that I need service. So like, all that data, moving it around and transforming it ends up providing meaning for somebody down the line. This is one definition I specifically found, which is the collection and manipulation of items of data that produce meaningful information. Like I said, it basically means everything. This is everything in computing. It's what we do, right? Today, we're going to focus on integration style use cases. So moving data around via messaging middleware and batch transactions and those kinds of things, and doing the types of work that we do with those style use cases. But to start off, I want to tell you a little story. There once was a developer with a horrible boss. You might have heard this story before. Maybe you've even seen it before. He had crazy projects with ridiculous timelines. You know, he expected you to generate ridiculous amounts of software without any kind of real rational understanding of how long it takes. And so he'd set these deadlines like the end of the week, or in our case today, the end of this talk. And there was a new policy that he came by to talk to this developer about, and that all TPS reports now need to have cover sheets. And it was my responsibility to make sure that actually happened. And so I was responsible for developing an ingestion pipeline. This pipeline was supposed to make sure that all the TPS reports had that cover sheet, and that it was stored accordingly. Then my other boss showed up. He had wanted to deliver requirements from the enterprise architect. He had a checklist that I had to make sure that we covered. So I have to use microservices. It's the corporate standard now. I'll be receiving reports via RabbitMQ. I've got to store the reports in MySQL, the database. I have to use production grade monitoring. This has to be a production grade system, so I need to be able to monitor it, make sure everything's working. I need to be able to have alerts if things go down and so forth. And all this needs to run on Kubernetes. Did I mention I got to get all this done by the end of the talk? We're now down to an hour and 50 minutes. It's a lot of work. So we better get started. So how are we going to do this? We're going to start off by just implementing some business logic. Okay, we're going to implement some business logic and expose it to Spring. That's it. Okay, and we're going to do that by implementing a simple Java function. No interface to worry about or anything like that. Just simple Java util function. That's it. What that function is going to do is it's going to take in the TPS report that as we get it off Rabbit. It's going to add a cover sheet and it's going to return it. That's it. And we will expose that as a bean to Spring. So this is obviously a Spring talk. So that's kind of what you do, right? You expose things to the Spring container so it can take care of things for you. That's all the code we'll write right now. Let's go ahead and actually take a look at what that would look like for us. So I'm actually going to take one step back and we'll look at our source first. So I need something to generate data for me for our conversation today. And so I've written a way of generating TPS reports. This is going to be, these TPS reports are going to be mind-numbingly simple. All it is I've got a function here that returns a hash map with a single string called report. And it says this TPS report ID, and then it's got a random UID. So my TPS report is nothing more than this object, okay? And I'm going to expose it to Spring as a supplier. So if you're unfamiliar with the functional interfaces within Java, there is supplier, function, and consumer. Supplier emits something, function takes something in, does something, and returns something, and consumer takes something in. So in this case, I need a component that will generate data for me to test out my system. So in this case, I'm creating a supplier. So I've got, like I said, just a simple Spring Boot application. I've got a supplier, which is nothing more than a Java interface, exposed as a bean. So the only Springy stuff I've got here is Spring application and bean. That's it. The processor that's going to add the cover sheet for me is here. So here, again, simple Spring Boot application. At Spring Boot, I get my main method like you always do. I'm using bean to expose. In this case, it's a function. My function has nothing more than it takes in that map that my supplier was giving me. I add a cover sheet on it, and I return it. That's it. Okay. That's all the code I need to write to implement the business requirements as they've been presented to me, right? But the business requirement was add a cover sheet to the TPS report. Didn't say about my business doesn't care how I connect to Rabbit. My business doesn't care how I run in Kubernetes. My business cares about this code specifically. That's it. Now that I've got a function that implements my business logic, now what? How do I actually connect that to Rabbit? How do I actually get that ingesting data off of that queue? And so we're going to use a framework called Spring Cloud Stream. And so Spring Cloud Stream is a framework designed for building message-driven microservices. So when you think about microservices, a lot of people's brains immediately go to a REST API that's powering a website or something like that. And that's fine, that's great. But you can use microservices for a number of different things. And in this case, these microservices are consuming and producing messages off of some type of middleware somewhere. Functions serve as the foundation of Spring Cloud Stream. So when we think about Spring and the building a Spring application, you've got Spring Framework and Spring Boot at the foundation of everything, right? It provides the app bean annotations and the dependency injection container. It provides the testing capabilities. It provides all that great goodness, property handling, all the things that you need to build a basic application today. Sitting on top of that, in our case, is an additional framework called Spring Cloud Function. And so Spring Cloud Function allows you to orchestrate function implementations within the Spring context. So you've got your Spring application, you've implemented your business logic via functions. Spring Cloud Function allows you to make sense of that within a Spring context. Sitting on top of that is Spring Cloud Stream. And Spring Cloud Stream knows how to expose those functions in a particular way, in this case, via messaging middleware. One of the advantages of Spring Cloud Function is it also allows you to expose these functions via other capabilities. Let's say you wanted to take the same business logic and expose it as a REST API, or via RSocket, or via some other way of communicating, TCP for all you care, right? Spring Cloud Function allows you to implement your business logic without any external dependencies and then expose it how you need to. In this case today, we'll be exposing it via Spring Cloud Stream and messaging middleware. Spring Cloud Stream is really difficult. You basically need to implement one of three interfaces. It's the functional interfaces, so supplier, function, and consumer. With that, in the right dependencies, you get a microservice. When we think about orchestrating these microservices and what Spring Cloud Stream is actually doing for you, this is kind of the hello world of a Spring Cloud Stream application, if you will. So I've got a time function, a microservice, a transformer microservice, and a log microservice. The arrows in between those are my messaging middleware. So it's how I communicate between these. And those red arrows, that's what Spring Cloud Stream abstracts away for me. So I don't need to worry about what middleware I'm talking to, how I connect to it, all the various aspects of connection pools and all that kind of stuff. Spring Cloud Stream handles all that for me, creating the topics and exchanges and whatnot. Spring Cloud Stream handles all of that stuff for me. It does that via the concept of a binder. And the binder is that abstraction around each one of the specific messaging middlewares that we support. And so we support a number of them. We support RabbitMQ. We support Apache Kafka. We also support specifically Apache Kafka Streams as a separate binder. Amazon Kinesis, Google PubSub, Solus PubSub Plus, and Azure Event Hub. These last couple, I'm sorry, and also Apache RocketMQ. Most of them, except for the Rabbit, Kafka, and Kafka Streams, all the other ones on that list are community-run projects that tap and implement our stuff for your use. So let's see. With regards to how we're going to do things, we've knocked off the first two things on our architect's checklist. So we've created, with Spring Cloud Streams, we can create a microservice with our function, and we can receive reports via RabbitMQ. Like I said, all I need to do for my applications, in fact, I can go ahead and we can take a look at that really quick, is we can go over here and take a look at the POM and take a look at the dependencies. So on my processor, I've got, where's it at? Spring Cloud Stream Binder Rabbit. So that's the piece that is actually going to enable my microservice to connect to Rabbit. If I wanted to swap it out for Kafka, all I need to do is there. And I now have a microservice that'll talk to Kafka instead of Rabbit. So the next step on the checklist is store reports in MySQL. So MySQL, sticking message into a database. This feels like something that is frequently done, right? Like the idea of ingesting stuff into a database. This is something that everybody has to do, right? So this feels like something that I shouldn't have to write code for. Spring is pretty good about providing stuff that will do boilerplate stuff for me, right? And so, in fact, they do. In this case, Spring provides a list of stream-based applications that we can use to handle use cases like this. So you can read from a file, you can ingest HTTP data, you can read from a database, a whole bunch of things. You can do processors, counters, filters, all those kinds of things. And you can write to Cassandra, HDFS files, and including JDBC. There's actually 66 different stream applications that are available to you to be able to build these kinds of pipelines without writing any code. When we use that JDBC sync, which is an out-of-the-box Spring Boot application that we will use, we're going to have to configure it. So we're going to have to provide some stuff that tells it how to run, basically. And so for us, we're going to provide these properties. So we're going to provide the driver. So how do we connect to my database? In this case, I'll use Mariah to connect to MySQL. What are the columns that I'm going to insert into? So what are the columns of my table? What is my table name? TPS reports, and the columns I'll be inserting into our cover sheet and report. I need to provide a user and password as well as a URL. The username and password, I'm going to configure these the lazy way today. You can get more robust with using secrets and that kind of stuff behind the scenes if you want. That's another topic for another talk on another day. So now we know how we're going to store our reports in MySQL. Production grade monitoring. Well, we can start off with MICROMETER. So first step is, how do I get the metrics out of my application? And the easiest way for us to do that is using MICROMETER as a framework. Here, if you're used to thinking about logging and are familiar with the framework SLF4J, which basically abstracts away the underlying logging framework you're using to allow you to swap out those logging implementations, think of MICROMETER as the same thing. So here, I've got my API in my application. I depend on MICROMETER. I can instrument it however I want. And then MICROMETER has a collection of implementations that will export metrics to the appropriate backend. So whatever backend you choose to use, MICROMETER supports, and you swap those out as you would expect. One of the additional advantages of MICROMETER is it's already baked into most of the Spring frameworks. So Spring Boot, Spring Cloud Stream, all the pieces that we're going to be used today, MICROMETER is already baked in. So I don't even need to instrument my application. All I need to do is, again, add the appropriate dependencies and things just work. Backends, though. MICROMETER supports quite a few of them, to be nice. Just like I said, just about everyone you can think of. And so which one do we want to use? There's a number of different options. We're going to stick with one that I find super easy, and it also happens to be from VMware, called Wavefront. And so Wavefront is a monitoring backend that VMware provides. It is a commercial SaaS offering. So if you're interested in checking it out, go to wavefront.com and register. It's free to register. It's free to get an API token to try it out. And it'll provide dashboards and those kinds of things out of the box for you. Because what I'm looking for is production grade, but easy. I don't want to have to spend time mucking with installing all kinds of different additional software and configuring it and all that kinds of stuff. Wavefront, in this case, all I need to do is provide an API key and a URL. That's it. Everything else Wavefront handles. Here's an example of the configuration specifically for Wavefront. So I need to enable it. So yes, I want to enable it. I provide my API key. I provide my URI. And then I'm also going to define a source. So within most metrics platforms, you've got the concept of a source. This is the source of data. In other words, what is the stream of data I'm getting from? And so in this case, I'm going to define my source within Wavefront as scdf-cates. And then when we go into Wavefront, you'll be able to see, we'll select the appropriate source, and that will confine the metrics down to the systems that I'm interested in. That'll take care of production grade monitoring. Now we have to run all this on Kubernetes. I'm going to keep going. We'll go ahead and the demo will take up more, so we'll do the demo after this. So Kubernetes, how do we get running on there? Let's see. In order for this system to run, I need to run Rabbit. I need to run MySQL. I've got a processor. I've got a sink. I've got that test source. On Kubernetes, that means I need to create a replica set service deployment pod for each one of those. That means a lot of YAML. So like I said, I was just checking the time. I need to get this done before the talk is over. So it's about an hour and a half. Looks like we're gonna be writing YAML for the rest of the day. Yeah, no, we're not gonna write. We're actually not gonna write a line of YAML. I don't like YAML, and we're not, because of that, we're going to avoid it. So we're going to use something called Spring Cloud Dataflow. If you're unfamiliar with Spring Cloud Dataflow, it is a system that allows you to orchestrate microservices on a platform, specifically two different styles of microservices. So streaming microservices, aka Spring Cloud Stream applications, as well as task/batch finite microservices. But what Dataflow really does is, like I said, it orchestrates. So when you think about, I've got source, processor, and sink, going back to my hello world comment earlier, I've got to configure for each one of those how to connect to Rabbit. I've got to configure what queues and topics to create, and I've got to make sure all these configurations match from app to app to app so that they all talk to each other. And I've got to maintain that so that there's no so that they're all in sync. Otherwise, this won't work, right? Dataflow handles all that for me. So I provide some basic configuration to Spring Cloud Dataflow, and it makes sure everybody else is talking to each other the way they should. There's a couple different ways of interacting with Spring Cloud Dataflow. There's an interactive shell. There's a web-based UI, which we'll be using today. And both of those sit on top of a set of RESTful APIs that you can consume directly yourself if you're interested. Spring Cloud Dataflow takes advantage of modern platforms. So I could run all these as JVMs on a single box. That puts a lot of onus on me with regards to making sure all the apps are up, making sure, noisy neighbors and all that kind of stuff. Modern platforms take care of all that for me. So they're going to make sure if my app crashes, it'll restart it for me. If I need to scale, they've got easy scaling capabilities for me. All that kind of stuff is built into modern platforms. So Dataflow specifically is targeted to run in those kinds of environments. So specifically, we support Cloud Foundry in Kubernetes. We also support local, aka running on bare metal, with an asterisk. That's specifically for batch use cases to replace a project that you might have heard of if you're familiar with Spring Batch, called Spring Batch Admin. So Spring Batch Admin was a Tomcat application. You package it up as a WAR file with your batch jobs, and then deploy that and run your batch jobs that way. Spring Cloud Dataflow, running in local, provides basically the same contract, so we do support it in local for that specific use case. This is actual executable code in Spring Cloud Dataflow. This defines 3 microservices: HTTP, filter, and HDFS. Each one of these is a Spring Cloud Stream application, and Spring Cloud Dataflow knows how to connect these together. The pipes in between each one define the hops in between each microservice. So going back to the conversation about Spring Cloud Stream and the binders and how they abstract away that messaging middleware, and that is basically the hop in between each microservice. These pipes here are the same thing. That's that hop in between each microservice. Everything in this ecosystem is really Spring Boot. So the Spring Boot for the Spring Cloud Dataflow servers, there's actually a couple components involved. The shell, the interactive shell I showed, is a Spring Boot application. And for the most part, all of the out-of-the-box applications are Spring Boot as well. And for the most part, we assume that yours will be as well. That being said, they don't have to be. If you want to write, let's say, a Python application to do some machine learning, and you're going to run this on Kubernetes, and you're going to Dockerize it up, as long as you obey the contracts of Spring Cloud Stream, which is basically input and output, or input or output, depending on which stereotype you use, you can deploy other types of applications with Spring Cloud Dataflow. The architecture of Spring Cloud Dataflow looks kind of like this. So you've got the Dataflow server sitting in the middle. It interacts with a relational database, really just to do some basic metadata storage. So it's got to understand where applications live, where the bits are, some basic configuration understandings, as well as definitions of streams and tasks and whatnot, which we'll get to in a bit. So it stores all that in a relational database. Over on the right, you've got the shell and browser. Both of those are interacting with Dataflow, again, via that RESTful API, so basically talking via the same channel. And then you've got the apps on top. Now, it's important to remember with Spring Cloud Dataflow, Dataflow itself doesn't do any of the work. So when I deploy, let's say this ingestion stream that we're talking about, the TPS report source, the processor I'm talking about that we created, and then the sync, the JDBC sync, that's the out-of-the-box application. When I deploy those are 3 independent applications that will be working independently of Spring Cloud Dataflow. In theory, I could start up Dataflow, launch those apps, and shut Dataflow down, and everything would just keep working. With that, I've got everything set up. So let's go ahead and talk a bit. Let's actually see some of this in action. So let me give you a little tour of what I've got running, and we can go from there. So this is obviously an online real-time demo, so I don't trust the internet, so I'm going to use it as little as possible. So I'm actually using Kind as a Kubernetes installation running locally. And so I've got 4 things running right now. I've got MySQL, I've got Rabbit, I've got my Dataflow server, and Dataflow behind the scenes uses another component to do the actual deployments of stream applications called Skipper. And so I've got all these running. In MySQL, I have already created a database with the table definition that I need for my to ingest those TPS reports. And then I've got Dataflow. You'll see I've got this F here. I'm port forwarding that so that I can, for ingress, so I can actually access that with a browser. And so if we go ahead and go over to Dataflow itself. So this is Dataflow running on that Kubernetes cluster. There's a number of tabs. Let me give you a quick tour of Spring Cloud Dataflow. And so I've got apps. So these are applications that are I'll be registering. I've got runtime. So this is going to show me what applications that Dataflow is responsible for that are running. Right now, I don't have any. Streams. So this is where we will define stream-based or Spring Cloud stream-based flows. We'll be doing that in just a minute. Tasks. So this is for orchestrating finite microservices. So batch jobs and those kinds of things. We realize that Spring batch jobs is a special use case within Spring, within tasks. And so we have some screens around this as well that we'll get to much later. And finally, audit records. So as things happen, who's doing them, why are they doing that, and all that. So apps. So like I said, Dataflow orchestrates. And in order for Dataflow to orchestrate applications, the first step it needs to do is it needs to understand, where do I get the bits, okay? So if I'm running on Cloud Foundry, I need to know, where am I going to get the jar file that I can do my CF push with? Since we're running on Kubernetes, where do I get my Docker files to run with these applications? So step 1 is to add some applications. So let's go ahead and add an application. I'm going to register 1 or more applications. And we'll start off by registering our source, that TPS source that we talked about. TPS. I have to select a type. So the type in this case is going to be a source. It emits data, so that's going to be our source. And I need to provide a URI. So in this case, I'm going to be looking for a Docker image. We're running on Kubernetes. So I want this TPS source latest. And then in this case, I don't have any metadata URIs. You can develop, when you develop your applications, if you have properties that need to be configured, you can use a plugin, a build plugin that will generate metadata that Spring Cloud Dataflow can use to simplify the configuration forward. And we'll look at that when we use the JDBC one later. I don't have any applications already registered, so I don't have to worry about the force. Go ahead and register the application. So what I've told Dataflow with this is I've said, I've got an application named TPS, and to get the bits, you're gonna be looking for a Docker image at this path. So Manila TPS source and the tag the latest. Okay. When Dataflow goes to deploy this, it'll go out to Docker Hub, pull that image, and launch it for me. Let's go ahead another one. In this case, we're going to add our processor. I'll just call it P1. This is going to be a processor. I've got my processor. So that application. So those are my custom applications. Now, I mentioned before that Dataflow has 66 different stream applications. We simplify importing that with this bulk import application. So in this case, we provide each one of the sets of applications out of the box. We provide them with Rabbit or Kafka, either one, and then Maven or Docker. So Maven, probably if you're running on Cloud Foundry, Docker if you're going to run on Kubernetes. So we need the Rabbit one with Docker, since it's running on Kubernetes. So we want to click on this link. It'll populate this, and I can click import. And now, if you had your own set of applications you want to import, you could build. It's just a text file with the URIs in it. You could do the same thing here. And so now it's registered all 66 of those applications. So we got 68 total, and we've got, in this case, the JDBC sync is the one we'll be using later. Again, runtime, we don't have anything running. So let's go ahead and actually define our stream. So we're going to go ahead and create our stream. And there's two different ways you can do it. I can either type up here. So I could do, FTP pipe counter if I wanted, or I can drag and drop. And if you noticed, as I typed, what I typed up here reflected down here in the drawing area. And it's a two-way situation. So in this case, what we're going to do is we're going to grab my TPS source. We're going to grab a named destination that we will need later. Kind of humor me on that one. P1 and right, looking at need JDBC. So I've got my TPS source. Going to a named destination. I will explain why later. That destination is going to point to P1. That's our processor. And our processor is going to send data to the JDBC sync. I need to name my named destination. So basically what I'm saying here is the TPS microservice send information to a topic on Rabbit called input queue. Then processor pick data up from that input queue, do your processing, send that to the JDBC sync, and the JDBC sync will write to the MySQL. The reason I'm doing this is basically because that stream 2 is really what I from a business perspective, what I care about. Number one is really just to generate test data, since we're just going to be doing this on the fly. In a real world, obviously, that would just be coming in to me. So I wouldn't have my TPS source and I wouldn't have that. So this is kind of the way I've delineated it. The TPS source doesn't have any configuration I need. I've already named my destination here. My processor doesn't need any configuration, but the JDBC sync does. So we talked about that in the slides. So I go to options. So I need to provide a driver class. I'll use Maria. I need to provide my columns. So I've got cover sheet and report are the two columns that I'll be inserting into my database table. Batch size, we'll just make it 2 just for fun. Data source URL. So I need to provide a URL. And you'll notice here in the URL, since I'm running on Kubernetes, I can use Kubernetes DNS so that I don't have to be specific with IPs or any of that kind of stuff. MySQL is the name of the service I'm running on Kubernetes, and so I can just specify that there. The table name I'm going to write to is TPS reports, and then did I pass username? Yep, skip username, root. And password is going to be password, which I'll copy over. Like I said, there is a more secure way of handling the username and password. For demo purposes, I'm running with this way. In short, do as I say, not as I do. That's all the configuration I need to provide to my JDBC sync. And so now when it receives a message, it will look for a field cover sheet, and it will map that into the cover sheet column. When it finds a report field, it will map that into the report column. Since we've got a map that has those two values, this will work out perfectly. Let's go ahead and update. And so now you can see it's updated the DSL up here as well. And so this DSL is basically that pipes and filters that I showed on the slide. So you've got P1 pipe JDBC, so that's the demarcation in between those microservices, and then dash each one of my properties I need to configure my application. So we go ahead and create these streams. I'm going to have one called input and one called processing. So go ahead and create the two streams. So we've created these two streams. Now it's important to note, nothing's changed here. Nothing has changed in Kubernetes. We're not actually running anything yet. All we've done is we've told Spring Cloud Dataflow, these are the definitions I want to run. These are the combination of the bits and configuration properties that I need to run these in a way that works. So in this case, I've said TPS is just going to write to that input queue. Input queue is going, or P1 is going to pick up off the input queue and send that to the JDBC. JDBC use the appropriate stuff with the configuration I've provided. So now let's go ahead and actually launch them. So now this is the point where I'm going to tell Spring Cloud Dataflow, okay, now run these applications on Kubernetes. And so I'll go ahead and start the processing. Here is where if I had any additional customizations, I could provide them. So things like CPU, memory, disk, count, so the number of instances. And then I can configure deployment specific stuff. So let's say I wanted to mount a volume to my Docker container. I could specify that there. And I could also I specified all those configuration properties on the JDBC sync in my DSL. I could also configure them here instead if I wanted. So if I click here, it gives me that exact same screen. So let's go ahead and deploy this. I'll go ahead and deploy the input one as well. This one doesn't require any properties either. And so now we've asked Spring Cloud Dataflow to actually grab the Docker images, push them out to Kubernetes, all with no YAML. And so if we go to runtime, I can see I now have two streams being deployed. They are in the deploying state. If I click on one of these, I can find all the Kubernetes related stuff. So the host IP, the phase it's in, all that kind of stuff. And now if we bounce over to here, so you can see they're all technically running. I'm going to go over to MySQL and I'm going to SSH into that. And we'll take a look at the database table and see if anything's getting there yet. Here's where we pray to the demo gods. Yay. Okay. So you can see I have data streaming in from, so going back to here, my streams, I've got my TPS source is emitting data to input queue. So if I went and logged into the Rabbit console, I would see a queue name input queue. And on the processing side, I've got P1 is picking data up off of that, doing its processing, adding our cover sheet so we're safe, and sending that to the JDBC sync to store that. Now, as that's running, and it's running live, I'll leave that running. We can also, we also said we had to have production grade monitoring, right? And so we said we would use Wavefront. And so if we come here to Wavefront, so this is Wavefront, they've got this integrations tab. So this is the Wavefront dashboard. When you log into Wavefront, you get this, where we started. And there's all these different integrations, all these things that just kind of work with Wavefront. The list is immense. But if I go Spring here, Spring Cloud Dataflow, cool. So if I click on this, I can get 3 sets of metrics. I can metrics and dashboards. So for streams, I can get a stream summary. I can get the stream applications. This will drill down further into the actual stream definitions themselves, the actual applications themselves, and tasks. So we're going to go to stream summary one. And so here, obviously, these applications are just starting up, so there's not a ton of pretty pictures yet. We'll leave this running. So I mentioned that source with the Wavefront configuration earlier on. So I need to look for scdf Kates. That's the source we configured. I have two streams running, that's right. One is that input one with the TPS source, and the other one is with my processor and the output. You can see they're both defined here. And if I go ahead and click on the streams, so source, select the source. So you can see I've got all these different applications here. They've got all the different metrics. You can also see I've run this a bit recently. So, okay, sorry, I go. So the processing one is actually the more interesting one. So I've got two app instances here. So you can start to see the dashboards starting to fill in. Obviously, this is all new. I'm just running this now. As we do more demos during our conversation, this will populate more. But you can see just out of the box with just some clicking, I get basic dashboards out of the box. So I've got CPU stuff, memory stuff, throughput rates, latency, etc. In this case, I've got the processing one selected, so there's no message source, but all those kinds of things. With that, I think now's probably a good time to take that 5-minute break. That seem reasonable, Bob?
That seems great.
Everyone.
Yeah, thank you so much. Whoa, you're zooming in. What's happening?
Don't look at me, that was
That was a really cool effect. Anyway, yes, everyone, take your we'll take a 5-minute break, bio break. Hope everybody gets to stretch their legs and get a little bit of water or something, and we'll be right back. See you in a few minutes. All right, my friends, we are back. We are ready to go and move on. Again, a reminder, if you have any questions, please put them in the Q&A section. Yvonne is doing his best to answer those. And also, we can still pass them along for tomorrow. So yes, make sure that you have any questions, put them in the Q&A. And then also tomorrow's episode will be same Zoom link. So you don't have to worry about, getting another Zoom link, same as today's. And if you missed a bit or you want to revisit some stuff, this will all be posted online in a few days as well. So anytime that you say, oh, I wish I could hear that again or go back, don't worry, we will post this so you can definitely review it at another time. All right. Michael, are you ready?
I am.
Okay. Away you go.
Cool. Thanks. So I'll go ahead and share my screen again. And so where we wrapped up before the break was we've got our demo running on Kubernetes. So we've got Spring Cloud Dataflow running. It's running by definition 2 streams. One has the TPS test source writing to a known place that we configured, and it's called a known destination or a named channel. And so that's called input queue. And then we've got our other, this is the one that my bad boss actually asked me to build. This is the processor that's going to add the cover sheet to my TPS report. It's going to pick the TPS reports off the input queue, add the cover sheet, pass it on to JDB, the out of the box JDBC sync. The JDBC sync is going to then write to MySQL. So we have the reports. One thing I want to do before we move on, though, is just a quick show of the POMs. So going back, like I said, here's our processor, very straightforward, Spring Boot application, Spring Boot main method, and a function. That's it from a code perspective, okay? There are 2 other aspects, though, to these things that are important. So let me spend a couple minutes reviewing them. So first of all, application.properties. And so here I need to say, since I could, in theory, have multiple functions, I could be sending these to multiple destinations. I need to map basically what's in and what's out. And so by default, there's this processor in 0, processor in 1, processor, etc. So I'm mapping each one of those, the in and out, to input and output. We can talk more about that with Oleg tomorrow. The other thing I need to do, though, is I need to expose some stuff. So in order for Kubernetes health endpoints to work with my microservice, I need to expose health info and bindings so that it will know whether or not my application is actually ready or not. If I left this app line out, what would happen is I would deploy to Kubernetes and I would get my applications running. They would run, but Kubernetes wouldn't think they're healthy, so it would restart it periodically. Obviously not a good thing. So that's the configuration within the application that I need to do. This is kind of boilerplate. You can copy and paste it to any one of your processors.
Let me interject real quick.
Sure.
Just on this particular screen, just to clarify what Michael is saying is that the line 2 and line 1 and 2 wouldn't be necessary, but because of what Michael said before, the data flow expects certain contracts from your application, the name input and output is something that is known to data flow, and data flow will be looking for those names. So that's why we had to remap the generated names to those names. Otherwise, in the pure Spring Cloud Stream way, we wouldn't really have to do that. So that's like an extra to adjust or adapt to a particular framework, in this case, data flow.
Good point. Good point. And so basically, you're left with as with everything with Spring, you're left with choices. So choice A is you configure everything Dataflow configures for you by yourself, and you don't use Dataflow, or you drop in these 2 lines and you let Dataflow do the rest of the work. I vote this way. It's a whole lot simpler. The other thing I wanted to walk through is the POM. So like I said, there's not a lot of code here, so there's a lot of stuff happening just because I added stuff to my application. And so let me walk through what we've got. So this is the typical normal Spring Boot application. I generated out of start.spring.io, so there's nothing magical there. I'm using Actuator. So again, Actuator provides a couple things with Spring Boot. It provides metrics. So that's one of the reasons we're able to get the micrometer and wavefront integration working well, as well as the health endpoints for Kubernetes. So that's how Kubernetes understands that our application is healthy and don't restart it. I then have a couple dependencies I need to throw in for wavefront. That's these three. After that, we already talked about the Spring Cloud Stream Binder Rabbit. And like I said, if you want to change it to Kafka, congratulations, you now have a Kafka app. Like it's really is that simple. Spring Boot Starter Web. So that is there because with Kubernetes, I'm using HTTP for my health indicators. So I need some way of exposing HTTP. So I use the web starter. It'll have a little web server in there that will enable actuator to be available via the web or via HTTP on port 8080. And that will allow Kubernetes to know that my application is healthy. Then I've got my test stuff, which in this case, don't be mad at me, but I didn't write any tests. Like I say, do as I say, not as I do. Dependency management. So I've got the Spring Cloud dependencies managing Spring Cloud Stream. And then I've also got Wavefront has its own Wavefront version control management as well. On the build side, I'm using the Spring Boots plugin to build my Uberjar, and I'm using Jib to build my my Docker container right now. The last thing I've got is live snapshot local. Well, I actually don't need that in this one. I'll need that in another demo we'll be doing in just a couple minutes. That's a tour of the POM. The POM for the other ones are all the same. So just want you to understand, without that, with that little code, obviously we lean heavily on our libraries to provide a lot of that additional functionality. So what specifically is there? And to be clear, I will have this code and the deck available on GitHub probably later today. So keep an eye out for github.com/mminella, and you'll be able to pick it up there. All right. So with that, we did what my boss asked, right? And we're done with before the talk was over. But remember that boss? Even after I showed him all that, he came back. Now, instead of getting TPS reports just from Rabbit, he's got somebody else that wants to give us files that contain TPS reports. They're not hip with the times. They're not doing messaging microservices and that kind of thing. So they just want to give us, here's a file OTPS reports. Of course, the other boss came back and he had more requirements from the enterprise architect. Let's see what his checklist is. So I have to use Spring Batch. I've got to minimize code duplication. So they don't want me just copying all that and doing it with a file source. I again have to use production grade monitoring, and again I got to run this on Kubernetes. Okay. And of course, this still needs to be done by the end of the talk. Otherwise, we wouldn't be talking about it. I got just under an hour. Roll up the sleeves. Let's get started. So the file format. This is what the file format is. The format of the file that we'll be getting to, each line has a TPS report record, like the ones that my source is generating. The only difference is it'll say. In fact, let me cat this really quick. It says that it's from a file. So here. So this is the directory that the input file lives. And what I've done with my Kubernetes cluster, so I'm running Kind. Kind is a single node Kubernetes cluster. I've mounted this directory, which is on my native operating system, as a directory on my Kind cluster. And then when we launch the Spring Batch job, we will mount that into the container that runs my batch job so that it will have access to this file. And so the file that we'll actually be processing is this. And so you can see this is this file-based TPS report ID. So the ones that are going from my source is just this TPS report. So we will know that the ones that came from the file are file-based. Right now, we basically have this running on our cluster, right? We've got the TPS source. It's emitting data to Rabbit. The processor is picking that data up from Rabbit, adding the cover sheet, putting it back on a different queue within Rabbit. The JDBC sync is picking up that data off of Rabbit and putting it into MySQL. What we're going to do is this. We're going to take a batch job that's going to read that file and put that data back into that first queue. That's why we used a named destination there, is so I know where to tell my batch job to write that data. So once my batch job, all it needs to do is read the data, put it in the format that the TPS source does, and stick it on the queue. The entire process down the line is going to be exactly the same. So I don't have to worry about retesting it. I don't have to worry about validating that it does the right thing. I know that everything is going to work as expected as long as my batch job's output is the same as the TPS's source's output. Easy peasy. And we'll do that with Spring Cloud Task. So Spring Cloud Task is a framework designed for building microservices that end. When we talked about microservices earlier on, I mentioned REST endpoints. We've already talked about message-based microservices. These are all microservices that are not intended to end. So if you get a microservice, one of those that fails, let's say it shuts down, Kubernetes restarts it. That's a bad thing. That's a bad thing. You might get paged from Wavefront. Again, bad things. Not all workflow, not all workloads though fit that model, fit that never-ending model. Batch jobs are one example of that. And so Spring Cloud Task is designed to build microservices that have that expected end. It has a few features. So first of all, it has a task repository. This is a relational database that is going to store things like start time, end time, the process result code. If an exception was thrown via that Spring Cloud Task, it will record that for you so you can come in later and check it out. It has Spring Batch integration, so it knows how to launch a Spring Batch application. It also adds in listeners so that you can understand, okay, when you're running a Spring Batch application as a task with those listeners enabled, you can get notifications that this job started, this job ended, this step started, this step ended, that I read this record or so forth. It also has capabilities around scaling. So Spring Cloud Task provides the ability to dynamically scale partitioned workloads with Spring Batch as well. It also has stream integration. So those listeners I mentioned earlier on, both at the batch level, which I mentioned, but also at the task level. So this task started, this task ended, and so forth, are all emitted via Spring Cloud Stream. Your batch application, when you're using these listeners, essentially becomes a source via Spring Cloud Stream nomenclature. So it emits messages via the messaging middleware, just like any other Spring Cloud Stream source would. All this is enabled via really complicated code by adding this annotation on your code. One of the newer features in Spring Cloud Task that we're working on and that I'm going to take advantage of today, and you'll be seeing in the next version in the month or so, is a single step batch starter. We realize that a lot of scenarios where you need simple ingestion, simple processing, even if it is complex processing and we just want to make it easier to build a batch application, this Spring Cloud Task Starter will help you with that. And so what it does is it provides auto configuration for common use cases. And so out of the box, it's going to provide auto configuration for configuring all the batch infrastructure that you already need, as well as a job, one chunk-based step, and then readers and writers for files, JDBC, Rabbit, and Kafka. So all of those you'll be able to configure an entire batch job using any of those components with nothing more than properties. Like I said, let's take a look. So if we go to my import job, so this is again a Spring Batch or a Spring Boot application. I've got my Spring Boot application annotation, my main method. I've got enable batch processing, so that's what's going to bootstrap the batch bits of this. So this is what's going to build out my batch infrastructure. If you're unfamiliar with Spring Batch, there's a job repository similar to the task repository I just described that has things like the job started, finished, step started. It stores all the state of a job. One of the advantages of Spring Batch is it's stateful, so you can restart it where it left off if an error occurred and those kinds of things. And so this at enable batch processing bootstraps all the infrastructure related to that. At enable task is the annotation I mentioned just a minute ago. It bootstraps all of the task-based infrastructure. What you see here is all the code in this application. I didn't write a single other line of Java code. If we go to the YAML file, here is the definition of my Spring Batch job. So I've got Spring Batch job. I've given my job a name. I've given my step a name, and I've set my chunk size to 5. So within a chunk-based step within Spring Batch, basically chunks are a way of dividing up a large data set into smaller pieces to process. So if you've got, let's say, 1 million records and to process, you probably don't want to process those all in a single transaction. So you configure a chunk size to be, let's say, 1,000 records. And so Spring Batch will start a transaction, process 1,000 records, commit the transaction, store that state in the job repository just in case something goes wrong, and then open up another transaction, another 1,000 records, and so forth, allowing you to always know where you're at. If something goes wrong, roll back to last good state and restart, etc. So in this case, I've set my chunk size to 5. I've got the flat file item reader. So I'm going to be using the flat file item reader to read my file. I've named it item reader. I know I'm real original. The resource is going to be /batch input /input.csv. And so I mentioned before that my input directory where that file is on my host OS, that will eventually, through a couple hops, get mapped to /batch input within the container on Kubernetes. So it'll look for /batch input /input.csv. Delimited is true. So this is a delimited file, although there's only one field, so it really didn't matter. I'm naming the field report. And so what's going to happen is this flat file item reader will return a map with one entry in it. The key will be the word report, and the value will be the string that it read out of the file. So that matches up perfectly with the format that the TPS source provided for that it put on the wire. So this way, Spring Batch will write the same things that the TPS source is writing, so that the rest of the pipeline works as expected. I've got strict set to true. Strict for this is the batch job will fail if there is not a file found. If you set this to false, if the file that you're expecting isn't found, it just says, I didn't have any data and shuts down. That's no big deal. So that's reading the file. Now on the Rabbit side, so I need to read from the file system, and then I need to write to that RabbitMQ. And so on the Rabbit side, I'm using the RabbitAMQ item writer. This, all I need to do is specify a name within Spring Batch. The rest I'll configure at the command just to show you how properties work when launching a task on Spring Cloud Dataflow. I could configure everything else here. I just want to be able to demo the other stuff. The last piece here is a property Spring Cloud Task Close Context Enabled. And so by default, backing up, Spring Cloud Dataflow runs applications on the streaming side as pods, right? So they're long-running processes. They have Kubernetes is going to restart them if they stop, all that kind of thing. We don't want that for a batch job. When the batch job stops, not if, when, we don't want Kubernetes to automatically rerun our batch job. That would be a bad thing. We're reprocessing the same data. So instead, we want it to shut down. Spring Cloud Task provides the capabilities that if you have, let's say, a component in there that may not automatically let your application shut down. So in this case, Rabbit connections won't let it automatically shut down. So I need to tell Spring Cloud Task when my batch job is done, shut the app down. And that's what this is doing. So what will happen is when I run this via Spring Cloud Dataflow, it will launch this application as a job on Kubernetes, which will start, process, and then the great part about it is it'll shut down. So it's only using resources when needed. That's all the code involved in my batch job. Let's take a look at the POM. So again, I got POM here. So I've got AMQ PS starter. So this is going to allow me to configure my connection, all the Rabbit stuff, right? How do I connect to Rabbit and that kind of stuff. I've got my batch starter. I've got my micrometer stuff. So we're going to still be we're still going to log the wavefront and all that kind of stuff. I've got my Spring Cloud Task Core and batch dependencies. I specifically am not bringing in the stream one because I don't want to use the listeners, and Rabbit would automatically cause those to kick in. I've got my Spring Boot Starter JDBC. Both task and batch require a database connection, so I need that taken care of. I've got my driver to be Maria, just like before. And then the last piece, the piece that is the piece that we're working on and provides really the magic of what we're seeing here, is this new starter. So Spring Cloud Starter single step batch job. That's all the code involved. Everything else is exactly the same. Let's go ahead and take a look at this. Actually, go back here. Yep. So with that, we've got Spring Batch checked off, minimize code duplication. We're using Wavefront for monitoring. That's great. And we're going to run Kubernetes. Let's go ahead and take a look at what this looks like when it runs. So I still have this running. So the stream is still running. We can even hop over to here. Go to MySQL. So you can see it, that's still running. And so now let's go ahead and do our task. Now, step one for anything within Spring Cloud Dataflow, if I want to run something with Dataflow, I need to register it, right? So I go to my apps, I'm going to add an application, register, and this one we'll call just T1. Again, I'm lazy. A type is going to be a task. So it's not a source processor sync, it's a task. The URI is going to be import job. So again, that's the map to my Docker container. I don't have any metadata for this. Now we're going to register the application. It's registered. So now if we go over to tasks, I can create a task definition. So this is just like creating a stream definition before. So we're going to tell Spring Cloud Dataflow, we just told it where to find the bits. Now we're going to tell Dataflow the combination of bits and configuration I need to actually run the application. So task. The cool thing about this application is I don't have any configuration that I'm going to specify in the stream. We're going to all do that when we actually launch it. So let's create task. And we can call this task 1. Create task. And so now to launch this, we're going to go ahead and do launch. And actually cancel. There's a couple options here. Show details is basically what we just looked at. I can launch task. I can also schedule the task. So on Cloud Foundry and Kubernetes, there is the option to schedule a task with the appropriate underlying scheduler. So on Cloud Foundry, there's a scheduler tile, and on Kubernetes, we use cron jobs. So if I were to schedule it, I would select schedule. It'll ask me for the cron expression to run the application at, and it'll run it on whatever interval or whatever my cron expression maps out to. We're just going to launch the task though. And so I've got two options here. I've got arguments and properties. Arguments are going to be passed via the command line, properties, environment variables, or mapped to basically deployment instructions of how I want my application run on Kubernetes. And so for this, I've got both. I've got arguments that are going to be, I need to set the RabbitMQ host. So where does the batch application know to talk to Rabbit? By default, it would be localhost. Obviously, that's not going to work in Kubernetes. I am using, though, Kubernetes DNS, which is nice. So I don't have to worry about IPs or that kind of stuff. I just say RabbitMQ. That works. And then Spring Rabbit template exchange, this is configuring where my batch application is going to write. What is the exchange that I'm going to write to? And so in this case, it's that input queue that we defined in our stream. So if we go back to streams really quick, that's this. So this maps back to that property. Let's go ahead and launch. Now, the other thing I need to do is I need to tell Kubernetes to mount that directory so I've got access to the files on my operating system. So it's a two-step process. First, I need to define a volume. And so in this case, I'm going to say the name of the volume and then the path, or basically where is it? Is it an NFS mount? Is it something else? With kind, it's nice. It's just a host path. So /input. This is where I mapped that directory we looked at to my host that's running kind. And so then volume mount is going to say, take this mount, batch volume, and mount it at this path. So if I were to SSH into the container once it's running and go to /batch input, I would see the same things as what I would see here. So they map directly. And with that, we can go ahead and launch our task. And so when we launch our task, we can go to task executions. Now, this is our review into the task repository. So like I said, we've got an execution ID, we've got a task name, start date, end date, exit code. You can see it's already running now. It's fast and it's done. And so if we drill in here, actually, before we do that, let's check our results because I don't want those. So we can pop over here. So if we go to select TPS reports, you can see these are the file-based ones that got imported in. So just in line with everything else, my batch job read that file, transformed it into what I needed to, and sent it, put on Rabbit. The rest of my ingestion process worked just the way it would as if it was receiving these via Rabbit originally, allowing that consistency across processing across both paradigms. So if we take a look at the task screen, so we got these executions. If we drill in here, we can see got the execution ID, the name. These are all the command line arguments that were passed in. So you've got, our data flow, or the wavefront configuration, the data source configuration, the external execution ID. So that's the execution ID of the job on Kubernetes. We do know that a batch job was run within this. We'll get to that in just a minute. And the execution ID of the batch job. Start time, end time, duration. Exit code was 0, which is good. There was no exit message. The resource was a Docker resource. These were the properties that were passed in, and then the platform properties. So these were the properties that were passed in to the deployer itself. And then we've got the log down here. Now, I mentioned that this was run via Spring Batch application, right? There's a Spring Batch job embedded here. And so Spring Batch has its own metadata that we can navigate. So job executions 1, so I can click into here. And now we see what the Spring Batch's job repository has. So here I've got my ID, my job name, my instance and execution ID. I didn't have any job parameters, start time, end time, duration. The status and exit code were both completed. There was no exit message. It executed one step. We can drill in here. So you can see there were 5,000 reads. There's 5,000 records in the file. So 5,000 reads, 5,000 writes, 1,001 commits. So obviously I need my chunk size was 5. So 5 times 1,000, that was 1,000 commits. The extra 1 commit was to find out that we were in a file. And if we go into the step, we can see, the IDs, the name, the type of step. So there's multiple types of steps within Spring Batch. In this case, it was a chunk-oriented step. Number of commits, duration, the number of records that were filtered, the number of ones that were skipped, the number of read skips, rollback, all the types of metadata that you'd want from production-grade batch solution. The other thing we should take a look at is we ran this with the wavefront dependencies, right? So we should have the metrics here. Now, obviously, a 6-second blip of a task isn't going to show a lot, but let's take a look anyways. So source. So you can see I've got one task. It contained one job, and you've got duration, job counts, and if there were active tasks, you would see that here as well. So we got our production grade monitoring. We've got our orchestration with data flow, just as the boss wanted. With that in mind, looking ahead, so data flow is currently working on 2.6 just came out. Some of the wavefront integrations are new there, so I would recommend checking that out. We'll be expanding that in 2.7. I'll let Oleg speak to. Oleg, do you want to chime in really quick? I'll put you on the spot since you're here. You want to chime in on anything with regards to upcoming features on Spring Cloud Function or Spring Cloud Stream?
Yeah, so you mentioned already earlier RSocket. I may even, if you ask me nicely, I may even do a quick demo tomorrow of RSocket. But so that's the big thing. We're kind of partnering with, not necessarily partnering, but working with cloud events communities. There's a demand to add support for cloud events. We're still trying to figure out what that really means within the context of Spring, and especially Spring streaming, like Spring Cloud Stream and Function. But yeah, those are the core things that are coming along. But like I said, the most exciting one is RSocket, and I'll kind of will explain to you why it is exciting tomorrow. So I'll stop at that.
Perfect. Thanks. And then on the Spring Cloud Stream side, the big thing we're obviously working on is that single step batch job starter. So like I said, with that, we're going to support flat files, databases, Rabbit and Kafka out of the box for our first MVP. If you have input on that, if there are other things that you think that should be included that you cannot live without, please chime in, let us know, either via Twitter or log an issue onto the Spring Cloud Stream GitHub repository. We'd love to hear what your thoughts are on that. Also looking ahead, Bob mentioned it at the top of the hour, or the top of the call, but Spring 1 is coming. This is the crazy time of year for the Spring team. All the releases going out, all of the talk preparation occurring. And I wanted to highlight a couple things specifically related to the topics today. So first of all, there's a workshop on Spring Cloud Dataflow. It's free. So you get to log in, play with Dataflow and all of its bits, being taught by those in the know. So I highly recommend taking advantage of this. Normally, the workshops at Spring Cloud or at Spring 1 are an additional cost. This is free, so please take advantage of it. Then we got a whole bunch of talks related to Spring Cloud Dataflow and the ecosystem we've covered. So I've got my batch processing talk. If during the second half of the talk today, when I was talking about jobs and steps and readers and writers, and your eyes glazed over and you have absolutely no idea what I'm talking about, come to my batch talk. It is going to be a Spring Batch 101 talk. I assume no knowledge of Spring Batch. You'll learn all about it there. Alaya and Glenn are going to do a walkthrough on Spring Cloud Dataflow. So they'll do an in-depth review of all the features and quirks of it. And they'll be using the latest version, so 2.7 with some of the cool stuff that isn't even available that I couldn't show you today. Mahmood is going to cover what's new in Spring Batch. So Spring Batch 4.3 is going to be coming out shortly, and so he's going to review all the new cool stuff there. Mark Heckler is going to be doing his game of streams, how to tame and get the most out of your messaging platforms talk. So he'll be talking about all the various aspects of streaming applications and kind of diving in and out of that. Oleg is going to be doing a couple talks. He's got his functions talk, so implement once execute anywhere talk. So I mentioned earlier on that one of the advantages of functions in Spring Cloud Function is you write your business code as a function and then you can expose it any way you want. So Oleg is going to talk about that paradigm and all the different cool ways you can expose that code. And then finally connecting your functions with RSocket. So Oleg said he's excited about the RSocket capabilities. Well, he's so excited that he wrote a whole talk on it. So highly recommend to check that out. Tomorrow, we'll be answering questions. We will also be probably talking a little bit, Oleg and myself, just with regards to what's coming up, what we think is interesting in the ecosystem, and anything you all want to hear or talk about. That's what I've got.
Hello.
Hey, Bob.
Hey, sorry, my feed bumped there for a second. How you doing?
Good.
Do you have time to answer some questions? Maybe Yvonne, you can pass some questions on to us that seemed like a good early time to do it. I'm looking over. Yvonne's been answering some questions. It's been really nice. Let's see. It seems Spring Cloud Stream is integration functionality, which Spring integration already does. So where will Spring integration fit in?
I'll actually defer to Oleg on that one since it's his
Yeah.
project.
So if you look at Spring ecosystem, it's a kind of hierarchy. So sure, you can connect to Kafka or Rabbit or Mongo or whatever using channel adapters within Spring integration. But the amount of legwork that you would need to do would be a bit more extensive. So Spring Cloud Stream made a choice to build certain elements of it on top of Spring integration. Obviously, we're eating our own dog food, we're utilizing our own functionality. And because Spring Cloud Stream is Spring Boot first type framework, that means we effectively provided we express certain opinion via certain auto configuration, effectively sparing you from doing all that legwork yourself. Kind of to what Michael was pointing out earlier when he said, you can configure all the data flow properties yourself, or you can sort of go conventional configuration and only override certain parts, certain things to fit in, and the rest is just slides right in. Michael, do you want to add something? Or
No, you hit it. Just to add to that, you know, one of the other differences between Spring integration and Spring Cloud Stream is the whole monolith versus microservices paradigm in general, right? So you've got Spring integration, it does amazing things. Monoliths are the right choice in a lot of applications. But when you think of the way enterprise integration applications were deployed, before the microservices world, you might have a war file with 5 or 6 integration flows in it with all kinds of different components and stuff. And so when you want to change that, you need to update that war file, retest the entire world, right? Because even though you changed only one component in it, you got to validate it didn't touch anything else. And that whole paradigm of getting that world through QA and processing and whatnot, scaling as well. You can't scale individual components within a monolith. You can scale Spring Cloud Stream applications independently. So let's say my processor was taking a lot longer, I could throw in another instance and, hey, what do you know, it works. That kind of thing.
Yeah, one last thing. Spring integration is not a requirement within Spring Cloud Stream. Yes, for Kafka binder and Rabbit binder, we chose to use Spring integration internally as internal implementation detail because it saved us from a lot of code because we relied on the adapters. But for example, there's a Kafka Streams binder, there is a Solus binder, there's other binders that absolutely are not reliant on Spring integration. So community binders, for example. So anyway, that's the answer.
Can you talk a little bit about schedulers and external support?
Sure. So I briefly mentioned the scheduling capabilities earlier with Dataflow. So Dataflow integrates with the appropriate platform level schedulers directly. Like I said, on Kubernetes, that's cron jobs. On Cloud Foundry, there's a scheduler tile that we do. That abstraction, though, it's a scheduler abstraction, right? And if you had a third-party one that you were interested in, implementing it yourself wouldn't be hard. So you could do that. We would also be open to talking to anybody who has third-party schedulers or whatnot that you'd be interested in integrating with. Please reach out to me directly. I would love to have more conversations about that.
Awesome. I actually have a great question about the workshops. Oops, where'd it go?
Is it the one around the pre-canned environment?
Yeah, will there be, what environments will be provided? There you go.
Yeah, so
will Spring One workshops provide pre-baked sandbox environments for attendees?
Yeah, so my understanding is that we'll be using a platform called Strigo. So that's the short answer, yes.
Okay.
And
obviously more information will come when you sign up for that workshop.
Exactly.
All that information will be given to the attendees in terms of what they need to have ready. Blah, blah,
exactly. Yeah. So my understanding is that it is designed to not have to, you're not going to have to install kind and 20,000 tools that your corporate lockdown laptop is not going to let you do. My understanding is that all this should work without having those constraints.
Yeah, that would be nice. That makes sense. Also, a reminder to everyone out there, registration for the Spring One workshops will open on August 31st. So mark that down on your calendar, because as far as I know, registration is limited. So if there's really a workshop, go now to springone.io, check out all the different workshops, and then if there's one that's speaking to you specifically, make sure you earmark that for registration so that you can get in there. We want you to learn as much as you can.
It's gonna be like conference tickets or concert tickets. Everybody hit refresh on the browser.
Exactly. Just refresh. Are other serverless frameworks supported in Spring Cloud Dataflow?
So Spring Cloud Functions supports serverless. So Spring Cloud Functions supports serverless with the adapters.
Yeah.
Dataflow itself does not. There's no integrations in Dataflow specifically. Oleg, if you want to dig in a little bit.
Yeah, as Michael said earlier, Dataflow is, I was going to actually jump in back there. Dataflow is the manager of apps, not the micromanager, but the manager. So in other words, once the app started organized, Dataflow, you can shut it down. But the app itself, it carries all the sort of functional and non-functional details through Spring Boot auto configuration. So now we're getting to the serverless platform. So yes, we can, and I'll show it to you tomorrow. I'm going to deploy that same function as AWS Lambda. So and then using it as basically decorating this function with various different behaviors. But yes, we support at the function level. We support AWS Lambda, Google Cloud Functions, Microsoft Azure, OpenWhisk, and so on and so forth. So yes, we support quite a few. And like I said, at the point when it is an app, I mean, if the app nature fits into the data flow, then yeah, data flow will run for you. But for data flow, it's just a jar.
Awesome. And I'll do one more question. Go ahead. What were you saying?
Yeah. Hey, Bob. We had a really good question. You guys mentioned that the Kubernetes substrate in Spring Cloud Spring Dataflow needing to restart pods. So any cold start time issues with using Java or Spring Boot? And also, have you been looking at AOT approaches to address possible microservice startup issues, for example, in Graal?
So as far as Spring Cloud Dataflow is concerned, it's launching a Docker container with the appropriate properties. So whatever you put in there is up to you. Let's start off with that. So with regards to startup times and those kinds of things, the Spring team across the board has done a ton of work on that with regards to startup times and cold starts and memory footprints and all that kind of stuff. You're actually going to hear a lot more about it at Spring One.
There's a keynote there's a keynote.
Yes.
They at the end, like not the morning keynote, the evening keynote, whatever that means actually. But yeah, so Sebastian Deleuze is going to actually talk about that specifically.
Yeah, specifically about Graal and our native image support. So yeah, so without completely taking away his thunder, the answer is yes, we're looking at it. To find out more, come to Spring One.
I believe they're called bedtime stories. I think you have keynotes in the morning, and the nighttime is the bedtime story.
And last but not least, this is not sort of a this is part of a spring. It's just one of those areas that maybe should be talked about more often than it is. But functional bean definition. So that has nothing to do with the word function or Spring Cloud function. It's just a way of not relying necessarily on Spring Boot configuration, but do a little bit of a manual work. But that provides a dramatic performance improvement.
Yeah,
And
functional bean composite, functional bean registration, lazy init, all that stuff is all helps.
Yeah, and you can just Google it because there's Dave Sayer's blog on that. There's many information on that. Yeah.
The good doctor, we like to call him, Dr.
Dave
Dave Sayer. Love that guy. All right, well, we are going to end a little bit early today, but what was great was Michael mentioned he's going to post up on his Git repo. And what was the Git repo address again? The stuff that you worked on today?
I don't have it yet. So I'll provide it tomorrow. I'll provide you the exact URL tomorrow. But otherwise, just my Git username is mminella, MMINELLA. So if you look there, it'll be the next repository I create. I guarantee it.
Perfect. Excellent. And then, oh, excuse me, my coworker just went pee-pee in the potty, and I'm going to give him a star. So
that's awesome.
Yep, I mean that's the work life we're living.
It is.
If we all got stars for going to the potty, it'd be such a more pleasurable experience. Anyway, so we thank you all for watching. Your great questions. We actually are saving. If you're like, wait, I had questions, we want to save those for tomorrow too. So we have marked them all down. And if you have any that you think of later, obviously bring those tomorrow. And Oleg, thank you so much for jumping in now and chiming in. This has been great. And Michael, again, thank you for all your presentation that you gave today. And again, tomorrow, same Zoom link. Just see you at 9 Pacific Daylight Time, PDT. And again, these will all be recorded, which of course they're being recorded, but they'll be posted later, and we'll send out those links on how you can access both today and tomorrow later. But for now, we'll say thank you, Michael. Thank you, Oleg.
Thanks for having me.
See you all tomorrow. Yeah.